welcome back, Honors Algebra 3, 4. I am Mr. Cardone, a.k.a. the King of Calculations, a.k.a. the, I lost it. I was just going to go with names, but never mind. I'm just Mr. Cardone. Okay, so today in polynomials, we're gonna see R3 is pretty big. There's a lot of stuff to it. So it's polynomial section. But today we're going to focus on, in this lesson, we're going to focus on the properties of exponents. We got three rules that are really cool. We have the power rule that says any variable, we'll say x to the power of a to the power of b is x to the a times b. So when you have a power to a power, you multiply the exponents. And then we have what's the product rule, and that says when you're multiplying two variables, we can add their exponents. So x to the a times x to the b is equal to x to the a plus b. This is a very rhythmic math lesson. I'll show you what I mean in a bit. And then quotient rule, division, right? When you have x to the a divided by x to the b, that is equal to x to the a minus b, okay? All pretty cool stuff, right? All right, we got some rules here. Now let's try some examples. I'm going to erase this here. Let's say I have 3x squared y cubed over 4x to the third, y to the fifth. And we're going to raise this to the second power, okay? All right. So everything in here is being applied to that 2 exponent. So I want you to recognize the difference between exponents and coefficients. Coefficients are the numbers in front of the variable, right? This 3 is a coefficient, so it doesn't act like an exponent, right? We're going to raise this 3 to the second power. 3 to the second power would equal to 9, okay? 3 to the second power would equal to 9. Now we're going to use that power rule that we talked about for the first time that has to do with the exponent. We have an exponent of 2 and an outer exponent of 2. So we have x to the second to the second. So the power rule says in that case to multiply the exponents together. So x to the second, well, that's just x to the fourth. Now we have y to the third to the second. So again, a power to a power, y to the third to the second. 3 times 2 is 6. So I have y to the sixth. All right, now look, everything in this quotient here is everything in these parentheses is being raised to that 2 power. So I need to take this 4 coefficient and raise it to the second power. So again, the coefficients don't behave like the exponents. We don't follow those rules that we had just mentioned. 4 to the second power is 4 times 4, so that's 16, okay? Now I have x to the third to the second. Well, that's just x to the sixth because 3 times 2 is 6. Y to the fifth to the second, well, hey, that's y to the 10th. See how it's rhythmic? It kind of makes like a song almost when you do it. All right, now we need to simplify this. So you have the quotient rule when you're dividing. You can also look at it as, do you have more x's on top or x's on bottom? Because they're going to cancel each other, all right? So you have x being multiplied by itself 4 times on top and x being multiplied by itself 6 times on the bottom. So all of the x's are going to cancel from the top, and on the bottom, how many x's do we have left over? X squared left over, okay? X squared left over. And then 9 over 16, does that simplify? No, nothing goes into both 9 and 16, so this will stay. And then y to the 6th over y to the 10th. Do I have more y's on top or on bottom, and by how many? Yes, I have more y's on bottom, so I have y to the 4th on the bottom. All right, I'm going to put one up here for you guys to try. I'm going to steal it from the book. Let's try a couple. Let's do 3 to the 4th x squared to the 3rd. That'll be a neat one. And let's do this one as well. Negative 2m to the 6th over t squared z to the 5th. All right, so this is pretty neat. All right, so we've got here this base of 3, right? This base of 3, that's not an exponent. That's not going to behave like an exponent, follow those exponent rules. But we do have an exponent of 4, right? And when I have a power to a power, what do I do with the exponents? Right, I multiply. So 4 times 3 is 12. I have 3 to the 12th power. That's just going to be a huge number. 3 times 3 times 3 times 3, 12 times. That's a lot. That's a big number. And then I have x to the 2nd to the 3rd, so I can just multiply those exponents and I get x to the 6th. Did anybody get that? Hopefully you did. If you left, like I don't want to multiply 3 to the 12th in my calculator. That's just a huge number. I'm going to leave it 3 to the 12th, but you probably might have multiplied it if you tried this on your own. Let's take a minute to try this one on our own. It's going to be neat. Go ahead and try it. And we're back. So I have negative 2 to the 5th power. So I'm going to take that number in front, negative 2, and multiply it by itself 5 times. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Multiplying a negative by itself is neat because every time you do it, it changes sign. Negative 2 times negative 2 is positive 4. Times negative 2 again is negative 8. Times negative 2 again is positive 16. And finally, we would end up with negative 32. That's neat. And then I have m to the 6th to the 5th. So power to a power, we multiply those exponents. 6 times 5 is 30. That would be m to the 30th power. And then on the bottom, I have t to the 2nd to the 5th. So I have a power to a power, multiply again. T to the 2nd to the 5th. Well, hey, that's t to the 10th. Oh, look, exponent of what? There's nothing there. What's the exponent when nothing's there? Yeah, you guessed it, it's 1. So really we have z to the 1st to the 5th. So 1 times 5 is 5. So we have z to the 5th. And then we're going to look and see if we can simplify anything further. We have m's on top, but no m's on bottom to cancel them. We have t's and z's on the bottom, but no t's and z's on top to cancel. So, and negative 32, nothing's on bottom to try to simplify with that. So this is where we would leave it, okay? It's a neat lesson. There's a few more rules for exponents that I'm going to give you the next time we talk. We're going to roll them all together, and we're going to be able to do so much with these. Thanks for liking. Leave your comments in the comment section. Remember to hit the like and the subscribe button and tell your friends. Thank you very much. Y'all have a wonderful day.